In this video, we will learn more in depth about selenium. To recap, atoms have three subatomic particles: protons, which are positively charged, electrons, which are negatively charged, and neutrons, which have no charge. The atomic number of selenium is 34, which means it has 34 protons, and in a neutral atom, 34 electrons. A common oxidation state of selenium is -2, but it also forms +4 and +6 oxidation states. The atomic mass of selenium is 78.96 AMUs. When calculating the number of neutrons, you must take the atomic mass of the element minus the number of protons that element has. When calculating selenium's neutrons, you subtract its atomic mass of 78.96 minus the 34 protons, which gives you about 45 neutrons. Selenium is a nonmetal, but also sometimes is a metalloid. Metalloids look like metals, but behave more like nonmetals. Physically, they are shiny and brittle solids and are good electrical conductors. Selenium is solid at 20 degrees Celsius, and it is found as amorphous red powder in vitreous black pellets. Selenium undergoes covalent bonding, as it is a non-metal metalloid. A common oxide of selenium is selenium dioxide. A common chloride is selenium tetrachloride. Selenium is mostly insoluble except for a very complex process. The principal quantum number is the distance between the nucleus and the last orbital, and it decides the energy of the orbital. The angular quantum number describes the shape of the orbital and the subshell. The magnetic quantum number describes how orbitals are arranged in space. The spin quantum number determines the direction electrons are spinning in the magnetic field. Selenium has an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p4. The principal quantum number for selenium is 4. This can be found in the 4p4 part of selenium's electron configuration. Selenium has an angular momentum quantum number of 1. This is based off of the p subshell that selenium has in the last part of its electron configuration. Selenium has a magnetic quantum number of 1 and a spin quantum number of -1/2. This is based off of selenium's electron box diagram, which shows the last electron landing in the 1 subshell and has a counterclockwise spin. The Lewis structure and VSEPR diagrams show the bonding between the atoms of a molecule and the lone pairs of electrons that may exist in the molecule. Selenium has an electron geometry of trigonal planar and a molecular geometry of bent. These diagrams show the 18 valence electrons that the selenium dioxide molecule has. Because of selenium dioxide's shape, it has 3 resonance structures. A few interesting facts about selenium is that it is used as an additive in glass and can be used to reduce the amount of sunlight coming through architectural glass. It is also used in ceramics, paints, and plastics as a pigment. And it can be used in some dandruff shampoos as it is toxic to scalp fungus that causes dandruff. It is also used in photocells, solar cells, and photocopiers. Based on the periodic table, which element does selenium want to become in order to be stable with a full octet?